Okay, this is the lecture video for MAC1114 Trigonometry. We're in section 8.2 where we're going to take a look at the law of sines. The law of sines allows us to find sides as well as angles for any general triangle. So it's not necessarily a right triangle. It can be used on other types of triangles. So following are the three cases where law of sines can be applied, and those cases would be angle, side, angle. So in other words, if you're given, I drew a little picture for you for each of these cases if you have forgotten them from geometry. If you are given two angles and a side in between those two angles, in other words, if you're given a numerical value as this angle, a numerical value as this angle, and it doesn't have to be these two angles, just any two angles and the side that's in between them. This is just one way to draw the picture. So if you are given two numerical values here and a numerical value for the side, that's called an angle side angle arrangement of information, and law of sines can be applied to find the remaining sides as well as the remaining angle. Now, you're not going to have to apply law of sines for every single thing that you go to find on this triangle because if you have two angles, I think we all know that you can just go 180 and subtract those two angles to get the third one. So whatever the easiest way is to get each answer, we will certainly do that. But to find these sides in this case, you would apply law of sines, and I'm going to demonstrate that as we go through the outline. Another situation in which you will be able to start the problem with law of sines is if you are given one side and two angles where the side is not included between the angles. So two numerical values for your angles and then some side that's not in between them, either this one or this one. And the angles could be any two angles, just as long as the side's not in between them. That'll allow you to start the problem with law of sines. If you are given two sides and a non-included angle, you can also start the problem with law of sines. The only thing is that for this particular case, side angle, and I'm going to very much be emphasizing this, when you are given side and only one angle as opposed to two angles as in these cases, this is what we call the ambiguous case. And I have listed for you what that means with regard to how the solutions can come out. Because for these particular triangles, there's only one set of solutions. Whereas here it can go three different ways, and I'm going to discuss that down here. Here I talk about the ambiguous case, and I reiterate the fact that that can only happen when you're given two sides and a non-included angle. And that's why every single one of these starts off by mentioning it has to be the side, one angle case, non-included angle. So the three different ways that your solutions can come out for your triangle. Solutions is just a phrase we give when we're finding all the missing pieces, whether they be sides or angles for a general triangle. You could either end up in a situation, if given side angle, where the triangle doesn't even exist. And right away when you go to find the first angle, because it's the first thing you're going to find in this ambiguous case, you will start off by using, and I'll even put that here. Let's get another pencil. You're going to start by finding an angle using law of sines. But sometimes you go to find that angle by using inverse properties. Doing the inverse of a sine will allow you to find an angle. And when you go to do that, sometimes your triangle, because the value is inappropriate, your calculator will shut down on you, it will quit, and that is your signal that what you are trying to find is undefined. So when that first when finding that first angle implies that it is undefined, that's when you know that the triangle, no triangle exists. If you can't find the first angle, it's because the triangle cannot even be formed. Okay, then other times you'll go to start by finding your first angle, and you'll find out that there are only one set of values, and I'm going to go into a specific detailed discussion when we come to those problems. And sometimes when you go to find that first angle, you'll find out that the triangle can actually split into two unique triangles. And then you'll be able to find two sets of solutions. And that's because you'll have two triangles. When it says one triangle exists, when we discover that that's the case, you'll have one set of solutions. So this is what we refer to as the ambiguous case. Again, it only happens in cases where you are handed two sides and a non-included angle. Okay, you can either end up with the angle being undefined, that means no triangle exists. You can end up with one unique set of solutions, and sometimes the triangle splits into two triangles, yielding two sets of solutions. Okay, up here you see a summary of the cases that we are going to handle in this section and the next section. Once again, if you are given a side and two angles, that's one of the combinations, that I discussed right here, or angle, side, angle, that's this other one. You are going to handle, or side, side, angle, you're going to handle these cases using law of signs. Let's see where I can put that. And that is what we're discussing in section 8.2. However, if you are not given one of the three cases that I've discussed thus far, that means you're in the next section. And that section talks about what do we do if we're given on our triangle, our general triangle, two sides and an angle that's between the two sides. That's called side, angle, side. Or if we're not given any angles at all and we're just given three sides, both of these cases are handled using the law of cosines. That's in the next section. Okay, so just a little discussion of the cases that you're going to be handling here. I'll also be discussing with you just a real easy way to tell which law you're using. Okay, so this is just what I said verbally about how the ambiguous cases can turn out one of three different ways. I want you to also know this property. It's a general property from your geometry courses when you were studying triangles, and that is that when all is said and done and you find all your angles and your sides, the smallest side, the side that is shortest, should be across from the smallest angle. The side that is medium in length, you could also call that the intermediate value. The medium-sized side on your triangle should be across from the medium-sized angle. And the largest side, or what we could also call it the longest side, should be across from the biggest angle. Okay, so that should always be true. Kind of use it as a checking point, as a way to check whether your answers make sense. Okay, so now we get into this first example. We're going to be applying the law of signs, and let me discuss with you, before I jump into the problem, how the law is actually set up. What do we do to create the fractions that we're going to use based on the law of signs? So let's look at this one more time before we go on to the problem. This is the actual law of signs. Notice that it's just a set of three fractions that you can set up, you'll only be using 2 out of the 3 fractions at a time. So this is the way law of signs actually looks, and it's nothing more than fractions that are made up of a side and the angle that's across from it in the actual triangle. And whenever you mention an angle, you're going to be taking the sine of that angle, thus the name law of signs. So A is across from angle A, and you're always going to draw your pictures this way when you're left to your own devices with respect to drawing. A will be aside from angle A, angle B will be across from side B, and side C will be across from angle C. We're using lowercase letters to mention the sides, to represent the sides, and capital letters to represent the angles. I mean, you can use other symbols. It's just a real easy way to, make sure everything corresponds. Okay, now, any of these fractions, you're always going to just be using 2 at a time, so you don't need to set up all 3. You can just set up the 2 that are going to get you the specific answer that you're going after at that particular moment. These can all be flipped over. See, they can all have, instead of the sides at the top, you can have the angles, the sign of each of the angles at the top. So then it would look like this, and thus the comment, alternative forms are sometimes more convenient. Here's when they're convenient. If you're looking for sides, you should have the sides at the top in your numerator. If you're looking for angles, you should have the angles at the top, because this will cut down on one of the steps involved in solving. So this is just a comment that you may take the way it appears in the original law of signs and flip them all over. If you flip one over, you got to flip them all over. Okay, so the rundown on what you can expect as we work out these problems. So back to the first problem that we were about to solve. Okay, so you're going to notice that in all of these problems, if you are able to use law of signs, in other words, this is your clue that you can use law of signs rather than law of cosines, which is in the next section, you will have at least one complete pair where you have the angle and the side that is opposite to it. And then there will be one other pair where they're coaxing you into completing that pair. See that you have the angle but not the partner that goes with it, the side across from it. So they're they are coaxing you into going after this pair right here. But again, I was telling you I'd give you an easy way to tell whether you can use law of signs. Just make sure you have an angle and a side across from it where you actually have numbers. Okay, so in this particular problem, I'm about to set up 2 fractions using law of signs. I'm going to use this pair right here. Now I'm looking for, excuse me, I'm looking for a side. I'm being prompted into completing this pair right here, which means I'm going to be finding side B. And so I'm going to have my sides at the top. So it's going to be side B, which is across from the 45. And remember, anytime you mention an angle, you are taking the sine of that angle. And then my other fraction will be a side measuring 7, and then an 80-degree angle, and I'm taking the sine. And then all these problems are solved by, because they are proportions, when 2 fractions are equal, that's called a proportion, they're solved by cross multiplying. You want to isolate the B, therefore you're going to cross multiply sine of 45 times 7. Just swing that sine of 45 expression right across the equal sign. That's cross multiplying one way. Okay, that'll leave you with B all by itself. And then all you're going to do is put all that in the calculator. So that's 7 times sine of 45. And get that value divided by sine of 80. And I get, for this particular problem, for side B, I just got 5.03, and then of course you're going to round to whatever they ask you to round to. So make sure that you're reading the comments. In problems that have multiple steps, like specifically the application problems at the end of the section, you're not going to round to the designated decimal place until the final step of your problem. In between, you're going to hold the entire number, including all of the numbers after the decimal, in your calculator each time you do a step, and then round in the grand finale of the problem. So we just got, let's see, for B it says round to 2 decimal places, so that would be 5.03. Okay, so I have found one of the sides using law of sines. Okay, then I'm going to go after the other side. You might want to go ahead and find that angle. It doesn't matter at which point you find this third angle. You can find it at the very beginning or find it as I am doing right now. I would like to find side A, but unless I have this angle, then I can't go on with A. So this would be a great time to go ahead and find angle A. Okay, so this would be angle A. You know that the sum of the angles in a triangle is 180, so no need to use law of sines right now because you can simply find angle A by subtraction. Just go 180 minus the 2 angles that you've been given to see what's left over for this angle. And that would be 55. Okay, once you have this angle, angle A, then you can set off to find side A, back to law of sines. So it's going to be side A, which is across from the 55-degree angle, and you're always taking the sine of the angles when you're using law of sines. Okay, and then when you go to set up this other fraction, you can use any pair you want. I tend to use what I was given, the complete pair, just because you never know if you've made a mistake on something else. So the complete pair I was given was a side measuring 7, and then an angle that goes with it as its partner of 80. So just cross multiply so that this is not here anymore, so that you have isolated A, which is what it means to solve. Okay, so it's 7 times sine of 55. Get a value for that numerator, and then I'm dividing by sine of 80. You can also, plug all the numbers in at once. So this is rounding to 2 decimal places as requested, 5.82. Okay, so that's all 3 answers. Moving on to, and I want you to, notice the arrangement of things that you were given each time, so that you're more aware of, hey, when am I into the ambiguous case? Again, I'll just keep reminding you, only when you are given 2 sides and an angle that is not between the 2 sides. That's when you got to worry about, hey, is it 1 solution, no solution, or 2 solutions? What we were given to start here with is this angle was marked, this angle was marked, and a non-included side. Included means the side that you're given with a numerical value is the side that connects the 2 angles. So this was called an angle side arrangement of information, and therefore appropriate for the use of law of sines. Okay, and example 2. Solve this triangle. So you have in this triangle, a 37, a 56, and a 14. In this particular problem, you have an angle, and an included side. That was also one of the cases where law of sines applies that I discussed on the previous page. So you're being given an angle, side, angle arrangement of information here, and thus we can start the problem. We can, use law of sines, at which point you decide to use it. You can use it right from the get-go, or you can go and find this angle first if you'd like. That doesn't matter. So if you do go after angle A first, it will just be angle A is equal to 180. The sum of all three angles should be 180, but you need to take off the two angles that you've been given already to see what is left over for angle A. Okay, so 180 minus 37 minus 56, and you have 87 degrees left over for angle A. Okay, moving on to parts of the problem where we're going to have to use law of sines, and I'm going to make a comment here that when you go to find, the remaining sides, notice that you could either find, notice that you have to find B and you also have to find C. You are to find the smaller side first and then move on to the larger side. Okay, how do you know what the smaller side is? Well, what I discussed on the previous side. Smallest side is across from the smallest angle. Medium side is across from the medium angle, largest side across from the largest angle. So of the two sides remaining, notice that the C is across from 37, while the B is across from a 56. So this has to be the smaller side. It's smaller than the other one we have to find. Go after the smaller one first. So we're going to go C over its partner, which is the 37-degree angle, taking the sine as we work with that angle. Then we're going to set up one other fraction, and we do have a complete pair. We have the 14, and we have the 87 as its partner. An angle of 87, which we will be taking the sine of. We want to isolate C, so we're going to get this sine of 37 out of the way by cross multiplying it right across the equal sign. So it is no longer in the denominator. We have C isolated, and we're about to approximate the answer. So it's 14 times the sine of 37 divided by sine of 87. And that answer turns out to be 8.44 if we round it to 2 decimal places as requested in this problem. Okay, now we have one more value to find. And that value is side B. And as you find these things, you might want to toss them onto the calculator because that gives you more options as to how to finish the problem. Okay, so I know I want to find side B, so I need a fraction that has B in it. And of course, its partner is what I'll be taking the sine of. Then I need to set up one other fraction. I'm going to use the 14 and the 87 pair. Sides at the top, because I've already made that decision here. And then I'm going to be doing sine of 87. Okay, pretty simple. I think you'll like this section. So we're going to swing this sine of 56 right up to the top to get it out of the way so that B is isolated. Okay, so the approximate answer for B is 14 times sine of 56 divided by sine of 87. And that answer is 11.62. Okay, first two examples where we use the law of signs to find missing sides, and even missing angles can be found by it. In the last two examples, though, we found those missing angles just by subtracting. But sometimes, you don't have enough angles to do that. You need at least two angles if you're going to find the third one by subtracting. So you'll see we'll get to some problems eventually where you're going to have to use law signs just to find the angles as well. Okay, so in example 3, now we just get to a problem where you just need to draw it yourself. So, a couple of reminders there that when you're drawing your triangle, now you might not know exactly what it looks like. You do know it has 3 sides, and that the angles are going to be called A, B, and C, capital letters for the angles, and then the sides that are their partners are named using lowercase letters. So across from A, you're going to have side A. Across from C, you're going to have side C. And across from B, you're going to have side B. Then go ahead and put all the numbers that they've given you. You have 10 degrees for angle B. You have 50 degrees for angle C. And you have side B being equal to 7. So once again, you have been given angle, angle, non-included side. Angle, angle, non-included side, which is appropriate for the use of law signs. So first thing I'm going to find, I guess, is angle A, because I do have at least 2 angles, so it makes it easy to find angle A, or it makes it possible to find angle A just by subtracting. Take off the 50, take off the 10, so that's 180 minus 60, 120. Okay. So now that I do have the 120, I have 2 complete pairs. So I can use the 10 with the 7. Oh no, let's see. I actually only have 1 complete pair. I have the 10 and the 7 that goes across from it. That's not complete. That's not complete. Okay, so let's look at the decision that we have to make right now. We need to find A. We need to find C. You are to find the smaller side first. Find smaller side first. Okay, I'll just write that a couple of times and then I'll just verbalize it from now on. Okay, which one is the smaller side? Well, A is across from an angle that's 120 degrees, and C is across from an angle that measures 50 degrees. So this would have to be the smaller side of the 2 that remain. Okay, so I'm going to go after C. So I'm going to go C, use it with its partner, the angle of 50 degrees, which I'm taking the sign of, and then one other fraction, use that complete pair. So side measuring 7 at the top, and then sine of 10 at the bottom. Okay, then you're going to cross multiply your way to the actual solution for C. So take this expression, multiply it right across the equal sign. It's not there, and you have C is approximately 7 times sine of 50. Close that up, and then we're dividing by sine of 10. And that's 30.88 for side C. And again, in these problems, you've been asked to round to 2 decimal places. Okay. And I'll even put it here just in case we decide to use it in subsequent steps. Okay, so we have that now. We have angle A, and so let's see, the only thing that's left to find is side A. So of course I'm going to set up a fraction containing side A, and that forces me to also use angle A. And then I need one other fraction. Again, I'm going to use the 7 and its partner 10. Okay, so now we're going to cross multiply times sine of 120. Get that right up there, and that will allow A to be isolated. And then just pop that in your calculator. So 7 times sine of 120 divided by sine of 10, and you get 34.91. Okay, that completes number 3. Okay, moving on to example 4. 2 sides of an angle are given. Determine whether the given information results in 1 triangle, 2 triangles, or no triangle. So let's see if this is side-side angle, because that must be what they're giving us. Otherwise, they wouldn't be asking this question, because there's ambiguity if you're not certain, if you only have 1 angle and that angle happens to be non-included. It's side-side angle arrangement. Okay, so let's draw it and make sure that's what they're talking about, but they have to be, just from the way they're asking the question. So I'm just going to draw the triangle any old way. Make sure that I have side A across from A, side B across from B, and across from angle C, side C. Put the numbers in. Side A is 2. B is 1. A is 30. So you see, you can't start this problem off by going and finding an angle using 180 minus anything, because you only have 1 angle. So you're forced to find your first angle, unlike the other 3 problems that I've done thus far, by using law of sines. Okay, so I am being prompted into finding angle B, because do you see how that's a semi-complete pair? You have the side but not the angle. This is a complete pair. Okay, so I'm definitely going to use this pair, and I'm being prompted into going after the completion of this pair. So because I'm looking for angles, I will now be putting angle information at the top rather than side information, as I have in examples 1 through 3. So I'm going to do sine of angle B with its partner of 1. That makes up one of the fractions. Then I'll use this complete pair, sine of 30, with its partner of 2. Okay, I want to isolate this unknown. This time the unknown happens to be an angle. So I'm just cross multiplying by 1, and we all know that's not going to change anything. So it is sine of angle B is equal to sine of 30 divided by 2. Sine of 30 divided by 2. And that is 0.25. Okay, if you want to get an angle, you have to turn this into an inverse statement. That just means you're going to switch these two. You're going to bring this to the left side, this to the right side, and that's what allows you to attach your inverse symbol. So it's inverse sine of 0.25. That's what's going to actually be equal to angle B. Okay, go ahead and put that in. So it's second. Call up that inverse sine symbol and put in your value. And we find out that the angle B is 14.48. Okay, so if this is 14.48 degrees, we want to ask ourselves in this ambiguous case, again, look what you were given to start this problem. This is your clue that you need to be checking which of the 3 cases it is the minute you find your first angle. We have just found our first angle. So we're going to have to ask some questions here. Again, I want you to realize that what they had given you, I found that, so that wasn't given. What they had given you was side, side, non-included angle. And that's what I went over quite a bit on the first page, is that whenever you're given this arrangement of information, first thing that's what clues you into the fact that you are in the ambiguous cases. Ambiguity meaning you don't know which way it's going to turn out. It can turn out one of three ways. So at the moment you find the first angle. This is when you're going to check which of the three cases it is. At the moment you find the first angle, you will do the following. Always 180 minus the angle that you have just found, which was that 14.48. Sorry, at one moment I make my 4s one way and then I turn around and make them another way. So just be aware of that. Indecisive, I guess. Okay, so you'll always go, once you find that first angle, which is this 14.48 right here, you're going to go 180 minus that angle. And you're going to consider it as an alternative possibility for angle B. I say angle B because that's where we got this 14.48. So you will consider 165.52 degrees as a possible alternative for angle B. Is it possible? Okay, just, real quick before you decide, hey, should I draw a complete new triangle where I put my new alternative angle of 165.52? Well, for right now, before I go drawing a whole nother triangle, because I may not have to, I'm going to put the 165.52 right here and pretend as though that is the measurement for angle B rather than the 14.48. So if it was, recall that inside of a triangle, the three angles should add up exactly to 180 and should not go over 180. But yet, if you were considering whether this is going to work, isn't it true that 165.52 plus 90 pushes you over the 180 degree limit? So because of that, so since 30 degrees plus 165.52 degrees, since that is over 180, it would be impossible to use 165.52 for angle B. So every bit of reasoning that's running through my head as I make the decision about whether I should draw a new triangle and put this in place of this, I am writing it out for you. Okay, so I just decided not possible. Okay, so once you realize that you can't use that alternative angle, and in this side-side angle case, you're always going to be finding an angle first. Okay, and considering this alternative angle, can't use it, so therefore you just stick to the original angle that you found of 14.48. So that being said, we can continue finding any values that are still missing at this point. So now, continuing with the problem, I'm going to find angle C first. So angle C is equal to 180, take off the 30 that they gave you, take off the 14.48 that you found yourself. And you get angle C, that's just a symbol for angle. So 150 minus 14.48, and you get 135.52. So I found that third angle so far, and I just have one side left to find. Okay, so let's look at these answers here. Okay, a single triangle is produced. We just proved that to ourselves using all the reasoning that I've gone over a couple of times. We found out that this angle can be one and only one way, and it has to be a 14.48. Considering the alternative led to impossibility, and so I'm sticking with this one set of solutions. That means a single triangle is produced. Angle C, we just found out, is 135.52, the very first angle we found, which led us to all this consideration and reasoning, turned out to be 14.48. Okay, only thing left to find at this point would be side C. So for angle C, it was 135.52, and you are going to need that if you're going to find side C as your last value. So back to law of sines, it's going to be side C over sine of 135.52. And then we need one other fraction to continue with law of sines. Using law of sines here. And let's see, I think for that one I'm going to use the 30 and the 2. So let's see, I have sides at the top, so I'll put the 2 at the top and I'll do the sine of 30 down here. Then I'm going to cross multiply by bringing this right up here. Know that I have enough room to squeeze it in right there, so I'll just write it here. So C is 2 times sine of 135.52 divided by, so this would swing right up here, so 2 times sine of 135.52 divided by sine of 30. So C is approximately 2 times sine of 135.52 divided by sine of 30, and that ends up being 2.80. Okay, so from now on, when I get to any of these side-side angle cases, I will explain this verbally. I wanted to write it out, all my thoughts and comments about whether or not I should use a different angle in the location where I found my first angle value, and the decision was no, which means a single triangle is produced. I'll say those type of things verbally for the remainder of the problems. Okay, so that was examples 1 through 4, and in the next video, I'm going to stop this video here, and in the next video, what I'm going to be working on is numbers 5 through the end.